Good afternoon, ladies and gentlemen. My name is Zhao Xiang-Ji. I'm a PhD candidate from Southwest Zhao University, and now I'm a visiting student in Florence University. Today, I have a presentation about the effect of DENTS on rolling contact fatigue on the real material. In this presentation covers 4 parts: the background of the RCF problems of the real material, and the experimental method to review the RCF problems with a specific dent on the real surface. And then I will give some results and come up with the reasons for these results. And at last, I will give some outlooks in our future studies. As we know, the real contact system is a complex contact system. Unlike the gel and beers, which is sealed and simple, the real contact system is always operates in the open environment and may be affected by the third bodies, such as the soft bodies like the leaves or water. It may leave no adhesion problems, and then cause traction and braking problems. Like the hard bodies, like the flat goods, such as the minerals or the clothes, or the bodies rolled up by the passage of the trains, it may cause surface damage on the real and rear surface. It may cause the RCF problems in their surface layers, survive life subsequently. In China, the freight railway from Datong to Qinhuangdao is very important because it occupies 1/5 of the total coal transportation in China. The coals may have a high chance to drop into the various interface because such a large amount of transport value. Also, we also detected a similarly shaped crack on the high-speed rail trade, which is propagated at least 4.15 millimeters in depth, which may be caused by the surface dents. Based on the problems above, we have a small-scale experiment on the text machine. The size of the real rollers is 40 millimeters with a night contact. The contact width is 5 millimeters. In order to observe the surface damage, the evolution of the surface damage, we set the total cycles as 48, 72, and 96,000 cycles. And in particular, we also conduct two types of dents on the surface of the real material, which is impacted by the ballast from the railway and the steel ball from the bearings. Based on the former researchers, we conduct the steel ball dents as a steel ball dent and ballast dents on the real surface by using the impact pendulum. The weight of the impact hammer is 5 kilograms at a speed of 3.4 meters per second. Compared to the steel ball dent, the ballast dent has an irregular shape and a sharp edge. And besides, the ballast dent is shallow with a rough surface of the bottom. We also have a test on the resistance rates after impact process. But however, because of the limits of the text device, we cannot directly measure the stress along the vertical direction, but we can simulate it into abacus. From this table, we can find that the tensile stress is distributed on the shoulders of the dent, while beside and the maximal tensile stress locates on the subsurface of material. Okay, let's look at the surface damage on the SP dent. When the SP dent means the stable dent. Firstly, we define the area around the dent into two areas. That is the front area and the rear area. The front area is where the tangential force firstly acts on the dent. In the early age, we can find that the peelings initiates at the front area, where there is no obverse cracks on the rear area. With cycles riding, the dent gradually sealed and multiple peelings appears on the front area. After 96,000 cycles, the dents gradually worn off, and the multiple peelings dominates in the front area. The surface damage got even worse on the B dent. In the early age, there's just only denominations appears on the front area, while with the cycles riding, the denomination gradually evolves into the spallings. And in the last, we have detected long surface cracks around the dent, and the spallings becomes larger. Okay, let's move to the subsurface damage on the SP dent. Firstly, when the tangential force first acts on the dent, the material firstly accumulates in the front area while it is removed in the rear area. And besides, there are some dark dots around the dent. We saw that it could be the dislocations or the pile-up groups. With the cycles riding, the dark dots gradually climbs toward the surface and connect the cracks. And with when the dent is gradually worn off, the cracks turned to propagate towards the surface. The subsurface damage also gets worse around the B dent. In the first stage, in the earliest stage, we find that there is a density area at the bottom of the dent. And the cracks firstly initiate at the boundary of the two areas and move towards to the normal area. And with the cycles riding, the cracks goes around the dark dots and through various passes. And finally, because the sharp edge of the dent initiates the cracks and also leaves a large angle for crack propagation. As a contrast, we also have an experiment on the undefected rollers. From the two pictures, we can find that there's just only the surface crack is distributed uniformly, and there's just only short subsurface cracks on the undefected rail. From this table, we can find that the angle and the length of the crack increased when the dent appears on the real surface. These are the former researchers who have found that the front area already has a crash grains with high strength, which may be may be benefit for crack propagation. And when the tangential force first acts on the dents in the front area, the tensile force, which is divided from the tangential force, may tear the crack and accelerate the cruise. And another component force in the front area may compels the material slide into the dent, which increases the plastic deformation. However, in the real area, the shear force divided from the tangential force may remove the cracks and the deformations. So we can talk about the crack screws in the front and the rear area. Firstly, in the after impact process, the tensile stress increases the average stress during the cyclic test, fatigue test, which makes the crack growth fast on the shoulders of a dent. While in the subsequent test, the tensor force acts on the front arrow, accelerates the crack growth, while the shear stress acts on the rear arrow, removes the cracks and the parasitic deformation quickly. And besides, there is high strain in the front arrow, which will also benefit for crack growth. Based on the 3 points, we can conclude that the crack tends to grow faster in the front arrow. However, we also have an interesting finding is that there is still found down 1 inch layer on the bottom of dent. The hardness, the normal hardness of this layer achieves 12 gigapascal. We thought that may contribute to the rough and sharp edge of the ballast, because when it impacts on the real surface, it may generate notch heat in the impact porches, which may bring out the 1 inch layer. We will talk about the crack growth in the SP and B dent. Because of a sharp and rough edge of the ballast, on the one hand, it generates notch heat, which brings out the 1 inch layer. This is beneficial for crack propagation. And on the other hand, the sharp edge of a dent also concentrates the stress, which is beneficial for crack initiation and propagation. Based on the two aspects, we can conclude that the crack grows fast on the B dent. Then at last I will make some conclusions. Firstly, the maximum tensile stress locates on the subsurface of the shoulders of dent, which providing the field for crack propagation. And then on the unbalanced wear rate on the shoulders of the dent makes crack propagation, crack length varies in these areas. And the crack growth rate is as follows. It grows fastest on the B dent, then it is SP dent, and finally is on the unflexed dent. And it grows faster in the front arrow than that on the rear arrow. However, there are still some limits on our small-scale experiments. So the further works, we will focus on the validation of the appearance of 1 inch layer on the railway line and find the approach to apply this test result to the railway line. Thank you for your attention.
Many thanks, Xiang-Ji.